Alrighty. So, any questions about anything so far that I can quickly answer? Going once? Going twice? Alright. So, we are done with week 8, which was your midterm, and we're now in week 9, which is your introduction to arrays and pointers. Alright, so I guess it's a good time to tell you my arrays joke. Why did the programmer leave his job? Because he couldn't get arrays. There you go. Okay, so yeah, that's all I have. When we get to objects, I have another one. So arrays. Let's say, let me comment all this stuff out. Okay. So, let's say, here's my main. Let's say I wanted to declare, can you see this, Rigo?
Yes.
Okay. So, let's say I wanted to declare 1,000 variables, right? I would have to do something like A0, A1, A2, right? And so on, A999, right? So this would be if I wanted to declare 1,000 variables, okay? And you can see that this will be a lot of typing. I don't want to be typing 1,000 variables, right? What if I wanted to do 10,000 variables? Even more work. So fortunately, for that reason, programmers came up with arrays, and the equivalent to declaring these 1,000 numbers that you see on top would be just saying something like int a square brackets 1,000. Okay, so what this statement here does is it declares an integer array of 1,000 numbers. Okay, 1,000 integer numbers. Okay, what are these numbers initially? Could be anything, right? Now, in a little bit, I'll show you actually the values that are in A by default, but can you guess what they are? Huh?
Any number?
Any number, good guess, okay? It could be 0, it could be some garbage number, right? What we're saying is we're telling it, okay, reserve 1,000 memory slots for values to be stored in them, but what values are already stored in those memory slots, your guess is as good as mine, okay? And I'll run, I'll run this thing through a loop so you can see how, what values we have in it. But yeah, I call it garbage, right? Could be any number. So this here on top declares an integer array of 1,000 numbers, and the numbers, the actual numbers stored in the array are any numbers, right? Or I like to call it garbage numbers. Okay? So this is just declaring an array. So there's another way for me to declare an array, and that is if I said, well, let's declare and initialize an array. So now I'm going to do an array B of 3 things, right? Which is basically the same thing that I did on top. And now I'm going to give initial values to this array. So first of all, let's just show them, see what they are initially. Maybe I'll get lucky and I'll get zeros. So B0 is this. Okay, so this is my first element. Handle. So this is first element of array B. Okay. This number that I put in here, in between the square brackets, is the index. Okay, so first element of array B has index equal to 0. Okay, so that's my first element. If I wanted to show you the rest of them, and this is my second element, this is my third element. Okay, so this is me showing show the values or the elements of the array, okay, using the index. So I'm going to run the program, and there are zeros. Okay, so a lot of times the numbers that are going to be stored in the array initially before I provided specific values will be zeros, but don't count on it. Okay, so now let's say I wanted to change the elements of the array. Okay, so I'm going to change these values from zeros to, like, say 10, 20, 30. Okay, so this is going to be b0 is equal to 10, b1 is 20, b2 is 30. Okay, so this is me changing the elements, and then I can use this thing again to show you what these values are. Okay, and you're going to see, maybe I should put a little divider in there. Okay, and now the array changes to 10, 20, 30. Okay, so notice that this is my first element, and this is my last element. Right, the last element of an array of size 3. So basically, let's say this is my size of the array. Right, I'll call this my size, or how many elements we have in the array. So the index of the last element for an array of size 3 is 2, which is basically this piece here. This, the 2 is equal to the size minus 1, and it's always like that. Okay, so if I have 1,000 variables and I start my first variable at 0, the last variable is going to be 999 since I'm counting to 0. Okay, same thing with the array. So I guess my question to you now is, what do you think is going to happen if I go in there and I try to do 3? Right? What do you think? Give me a guess. Is it going to work? Is it going to crash? No idea? Okay, well, in other languages, like if you have Java, for example, or Python, if you have an array of a certain size and you try to give it something that's outside of this size, so this is an array of 3 elements, right? If I try to do something like b3 is equal to 40, right? What I'm trying to do now is I'm trying to tell it, okay, well, even though we have 3 elements, make the 4th element equal to 40. Okay, in other languages that are a little bit nicer than C++, you're going to get like an index out of range error, and the program's not going to work. What's going to happen in C++ is it'll work, but it's not going to give you the results that you expect. Okay, so you can run into a lot of issues because it's not going to provide you with an actual error that's going to halt your program. Okay, so just be careful, don't do this. Right, so this is bad. This is my index out of range. Okay, if I try to show this value, it will basically show the next value that is in the sequence of memory slots after the array. Okay, so what is it going to be? My guess is probably a 0 again, right? There's another 0. Okay, but that is not part of your array. Okay, you're going to run into some issues if you're trying to do this kind of a syntax. So this is also bad. That's your index out of range. Okay, so don't do this. So now you know what an index is, what an element is, right? So this is my element 1, right? Then I have my other elements, element 2, element 3, right? And then again, these are, let me move this here. These here are my indexes. Okay? All right. So this is, I showed you 2 different ways to declare an array. So the first line declared an array. This one here also declares an array. Then I went and I initialized the array. Okay? So this is me initialize the array. Okay? So I can do it another way. So I'm going to go and I'm going to create a third array. So this is int c square brackets. I'm not going to put anything in the square brackets. I'm going to make this thing equal to, I don't know, 2, 3, 4. Okay? So the number here is not needed because C++ compiler will figure out automatically that you have 3 elements and it will make this array size of 3. Okay, I can show you these the same way I did with the other one. I'm going to copy this here. Alright, and this time I'm going to change this just to C. Alright, and now you're going to see the elements of this array. Okay, I run it again, and there you go. C0, C1, C2, 2, 3, 4. Okay, so this is just the basics of declaring an array, knowing what an element are. So these are my different elements again. So this, and this are my elements. And if I wanted to, these are my indexes. Index, this is index 0, index 1, index 2. Okay? So an array, the name of the array is C. There's 3 elements in it. First element is 2, second element is 3, third element is 4, and the indexes for each of these elements. So now I'm going to go back to my original, my A array. Okay? And I told you that I want to go and look at the values of this, right? But I'm not going to go and copy paste this thing 1,000 times. What I'm going to do is I'm going to make a loop and I'm going to make some variable. I'll call it index because it kind of makes sense. Is equal to 0. Well, my index is, let's say, less than 3, and then index plus plus. So what are the values for this index that I'm going to get here? Index is equal to what? Awesome. So I'm going to get index is equal to 0, 1, 2, right? And that's exactly those are the values that I'm going to need to show you the array C. So instead of doing these lines 3 times, I'm just going to grab this thing here, I'm going to copy it, throw it right underneath my loop. I'm going to change this thing a little bit so that it shows a little bit different. This 0 here, I'm going to change it to I. All right. Less than, it's not I, it's index. And then here, C square brackets index. Okay, so I'm going to run this thing, and maybe I should have put another separator. So this is showing the array elements using a loop. Show the array elements, the elements of the array using a loop. Okay, run it, and that's this. Okay, so I can do the same exact thing that I did on top with just a single line of code. I did these 3 lines right here. So now that we know this, what I'm going to do is I'm going to basically just recycle this loop. I'm going to grab this thing, paste it in there. I'm going to change my index to less than. Let's say I want to show the array, this array right here, right? So I'm trying to show array A. What do I need to change this loop to? What does this need to change to? So for an array of 3 things, I had to make this 3. This is an array of 1,000. So what do I change this to? 1,000. Right? And what are the values that I'm going to get? 0, 1, 2, and so on and so on. What's the last one? 999. Okay? So now I'm just going to change this to A, right? And let's have a look at what my A looks like. Did I put a little separator? Nope. Let's throw that in there. And have a look at the 8. All right, and here you go, some garbage numbers. Okay, so there's lots of them that are actually zeros. And by the way, if you don't run this program in C-line, if you're running it in code blocks and opens up in the little terminal, it is not going to show you all these values. It will only show you the last 400 lines. All right, that there's an actual limit on how many lines the terminal is going to show. So you're not going to be able to see all these, but whatever. If you're using C-line, you get to see this. And the moral of the story is you have a whole bunch of zeros in there. Most of them are zeros, but they don't count on it. Every once in a while, you're going to encounter some garbage numbers. And if you're trying to do some kind of a math with these numbers, it's not going to come out right because they're not zeros as you expected. Okay? So now what I'm going to do is, now that we saw this thing's got some garbage numbers in there, I want to ensure that it's got a bunch of zeros only. So I'm going to initialize the array A using a loop. So I'm going to just grab this loop right here, copy it. All right, stays the same, and I'm going to get my A index, and I'm going to make this equal to 0. Okay, then I can go through this one more time and show it to you, and you're going to see that there is just a bunch of use range-based loop instead. Okay, great. Then we're going to look at A now is just a bunch of zeros. All right, so here's the whole array now, a bunch of zeros. Okay, and why did I show you this? Well, it's a quick way to initialize an array, right? I don't have to go and write a bunch of lines. I have 1,000 things. I wrote 2 lines of code, and now it's done. All right, any questions? So far, so good? Sure?
Yeah.
Okay, so what else do I want to tell you about arrays? So initializing an array element, array index, pointers. I guess I got to tell you a little bit about pointers because arrays and pointers are related in C++. So I don't remember. Did I tell you about pointers already? Don't remember? Okay, so here we go. So pointers, and by the way, pointers are used to create arrays in a way. Okay, so let's look at them real quick. So let's say I have a variable int x, right? And this variable int x is equal to 10. I'm going to show you that cout x equals x and L. Then what I'm going to do is I'm going to do a cout $x equals $x and L. Okay, what this one does, the one on the bottom, right, is the actual memory address of A. So if I was trying to show the value, right, this is the value that is stored in the memory slot for X, then this one right here, the $x, is the memory address for the memory slot for X. Okay, so let's look at that one real quick, and you're going to see that it is actually this number. All right, so that's my memory address of variable X. Okay, so let's just open up an Excel spreadsheet here. I can show you a little bit something here. Okay, so this is my variable name, and I have this is my value stored in memory, and then this is my memory address. Okay, all right, so this is my variable. Variable name is X. The value stored in memory is 10, and the memory address for this thing is this. I didn't copy it. Oop, I did. Okay? Does this make sense? So far, so good? Okay, so what is a pointer variable? Well, a pointer variable is a special kind of variable which is not going to be used to store an actual value. It will be used to store the memory address of another variable. Okay, so I'm going to go in there. I'm going to do int asterisk x, capital X this time. So this one is me declare variable x, and here what I'm doing is I'm declaring a pointer variable capital X. Right, the little asterisk in front of it indicates that it is a pointer. Okay, so let's have a look at the value that is in X. So I'm going to do a cout X equals X and L, and then I'm going to do a cout $x equals $x. Okay, and just like I did before, now I have a capital X. The value that's going to be in here, we're going to see in a second. The memory address is going to be something similar to this. Okay, so let's have a look. If I run this thing, my initial value for x is this 0x0. Right? So it's basically, that's like a no pointer, right? When you have a pointer that points to nothing, this is your null basically. All right, so the initial value that is stored in this, just like usually in the variables it is 0 most of the times, that is how in these pointers usually it's null. But just like with regular variables, you could get zeros most of the times, but lots of times you're going to get some garbage in there. The same rule applies to your pointers. Okay, so this one here is my pointer. Alright, so the actual value that is stored in memory for a pointer is just some memory address. Initially it's the null pointer, so it doesn't point to anything. And the memory address for this particular variable is this. Okay? So now what I'm going to do is, and by the way, every time I run the program, these memory addresses are going to change because my program does not store its variables in the exact same place in RAM every time it runs. So if I actually go in there and you copy this number, you're going to see that it changed, right? It's going to change every time. All right, so now what I'm going to do is I'm going to go and I'm going to tell it, okay, I want this one here, the x pointer, to point to my little x. So what's going to happen is I'm going to put this memory address right in there. Okay, how do I do that? I'm going to say this is point big X to little x. And I just say x, big X, is equal to %x. And remember, %x is how we get the memory address of some kind of a variable. Okay? Then I'm going to go in there, I'm going to check out my value for x, my memory address for x, again. And you're going to see that the memory address of x, let me see if I can increase this here. Right? So if you can see right here, so initially my little x is this hex number, and by the way, this is the reason why we had to do the hex to decimal and hex to binary, all these different number conversions. And why is there hex numbers in memory? Because there's a whole lot of them. It's a lot easier to write it in hex than it is to write it in decimal. It will be a shorter number with hex. So going back to this, %x is my memory address of x, right? Initially, the pointer x had nothing in its, content. Then, after I point it, after I do this line right here, I'm actually changing what's stored in x. So I changed from this to this. And what is this? Well, that is the memory address of a. Okay, the memory address of x itself did not change. Right? It's still, x still refers to some place in memory. It's still the same place. Well, the variable itself is still in the same place in memory, but the content that is stored in that place has changed. Right? So in other words, my x is this, right? This number. My memory location for %x is this number, right? And remember, these numbers are going to change. And the actual value, as soon as I do this line right here, then I'm changing the value right here from null to this. And what is this? Well, it's the same thing that this is, right? In other words, now the pointer x points to this little variable x. Okay? What's the purpose of this? Well, the purpose of this is that, let's say if you have a function and you're trying to send an array of objects. These objects can be really, really big. You're trying to send, a lot of stuff into a function. It is easier for you to pass a pointer to the original thing that you're trying to pass. Okay, in other words, you're not going to move things around in memory. You're just going to tell the function, okay, there's this place in memory that refers to a whole bunch of other things, and it just becomes faster that way. Okay, so I'll show you some examples of this when we do arrays and I start doing arrays and functions. Another practical application of these pointers is going to come in handy when we start doing data structures, and which is the next class, and we start doing dynamic memory allocation. Okay, so far what you're seeing here, these are static arrays. right? So I'm telling the program there's going to be an array of 1,000 things, and it's not going to change, right? There's no way for me, well, there are ways for me to basically ask the user to enter a number, and then based on that number, I determine the size of the array. But for the purposes of the data structures class, when we start encapsulating arrays inside of objects, and then you make a new object, and then you give the array a size, the only way for you to do that is using dynamic memory allocation, okay? Which is, we're gonna have to do some pointers there, okay? And that's the reason why I'm introducing pointers here. I'm also going to touch up on pointers when we start doing arrays and functions, which is, I think, next week. But for now, does this make sense? We sure? Okay, one more thing. So let's say, what's the purpose of having a pointer is to be able to change the variable or the array or whatever this thing points to. Oh, by the way, another application of pointers is when we start doing data structures, you have linked lists and trees and stuff like that. So then you basically create your own objects, and then one object points to another object, that other object points to another object. You can kind of link them in sequence, and that linkage is being done with pointers. Okay? So going back to this here, what I'm going to now, the next magic trick is I'm going to show you how I'm going to change this value from 10, which is what it is originally, right? Value of x is 10. I'm going to change it to some other number, but I'm not going to change it using x itself. I'm going to change it through x, big X, the pointer. Okay? So that's this piece here. So change the value of x using pointer big X. Okay? So I go in there and I say, okay, asterisk x is equal to 100. Okay? And then I'm going to show you, the next thing I'm going to do is I'm going to show the value of x, which is just cout x equals x, right? And I'm going to show you the value of x using the pointer big X. Show the value of x using big X. And that is cout asterisk x equals asterisk x. Okay? So this is the dereference operator if you wanted to change. So this right here, asterisk x, is going to change the content of the memory location that it points to, right? So since x points to little x, doing this right here will actually change this value right here to 100. So when I do this here, you're going to see 100, and when I do this here, hopefully you're going to see another 100. And if I run it, and you're going to see it right here, right? So both of them are basically the same thing. Make sense? Any questions? Okay. Let's see what else I want to tell you. Let me look at what I covered on Monday just to make sure I don't miss anything new. Okay. There's also two-dimensional arrays, right? Two-dimensional arrays are basically with two brackets. So if you have a one-dimensional array, that is the same as having a single line of numbers, right? So if you're looking at an Excel spreadsheet, right, and let's say I was looking at, what array did I make here? So let's say array C, right? So array C had 2, 3, 4, right? So that means that if this is my array C, some place in memory, these places in memory are in sequence. We're going to have a 2, then we're going to have a 3, then we're going to have a 4. That is if I have an array of C which looks like this, right? That is a one-dimensional array. Okay? Now if I wanted a two-dimensional array, the two-dimensional array will actually be just like an actual complete Excel spreadsheet. So it will have, come on, zoom in. It will have rows and it will have its own columns. Okay, and how we're going to do this? Well, it will be some kind of an array, let's say Z, and it's going to have square bracket, square bracket. Okay? And these are going to be very handy, especially if if you're trying to do this kind of operations like some kind of matrices and linear algebra or differential equations or something like that. Okay? I'm not going to get into this right now, but just be aware there's two-dimensional arrays, right? So a two-dimensional array is basically an Excel spreadsheet. If you wanted to add more dimensions, then you can make three-dimensional arrays, four-dimensional arrays, right? There's pretty much, you know, as many dimensions as you want to come up with, right? If we're going to be using a one-dimensional array, right? If it's going to be a single dimension, then the way you can do this using this syntax, or you can create a pointer z, right? If you're going to have a two-dimensional array, right, then you would be doing a double pointer, right? Asterisk, asterisk z, okay? There's pointers, two pointers, and so on and so on. But don't worry, we're not going to get into that too much. So this is the z and two-dimensional arrays. Now, the next thing that I want to tell you is, let me have a look. What else do I want to tell you already? Pass by value, pass by pointer, pass by reference. Okay, so I'll go over this in a second. Oh, and I got to show you recursion, right? Okay. So now that we've touched a little bit on arrays, let's go back to functions. Okay. So. And that's going to kind of illustrate the power of pointers, or the application of pointers. So first of all, let's say I'm going to go in there, I'm going to declare a variable k. Okay? What kind of a variable is this? Is this local or global variable? Global? Local? Okay, I like local. All right. So what is a local variable? It's a variable that is declared inside of a function. Which function is this? Well, it's my main, right? That's my main function. Okay, so let's say I'm going to go in there, I'm going to make another function. I'm going to call it void pass by value, and I'm going to call it k. Okay, int k. All right. And I'm going to copy this, and again, remember, this is my prototype. Make sure you have those to make it easier for yourself. I'm going to grab this thing, I'm going to throw it right after my main. Okay? And this is my definition now of the function. Alright, so the only thing that I'm going to do in here, first of all, I'm going to make this thing here equal to 0. And I'm going to make this thing equal to, k is equal to 88. Okay, so my question to you is, what is the value of k here? So I'm showing you k here. Then I'm going to call my function, pass by value. I'm going to send the k over. And then I'm going to show you the k after again. Okay, so what is the value of k here? 0. 0, okay. How about here?
Still 0.
Still 0. What's that?
Because you're changing, it's not the same, right? Okay.
Yes, so the value of k here is still 0. Even though I have a variable k here, this is a different variable k than the one in the main. Okay, so remember, when I have this variable here, what was the name for this kind of a variable? Starts with P. I heard it. Parameter. Okay. So this is my parameter variable, and what was the name for this variable here? Starts with A. Starts with A. Ends with argument. Okay? Argument. Okay, so the argument is the value that we pass into the function, and the parameter is the variable that receives the argument. Okay? Both of these variables, these are two different variables. If I went in there and if I did an %a here, let's do an %a right here. So I'm going to do a cout %k in pass by value %k, and then if I did an % here, ampersand k in main, right, is going to be ampersand k. Are these two going to be the same? Is this going to show me the same thing as this? No. Okay. So let's have a look. If you don't believe it. So in the main, I'm going to copy them in here because they're easier to see. So in the main, it showed me this address, and in my pass by value, it showed me this address. So both of these, each of these variables is a different variable. It refers to a different place in memory, which is why if I changed k here, I am not changing k in the main. Okay? So these are my local variables. Okay? So now what I'm going to do is, I'm going to show you how to do this in another way. So I'm going to erase this piece here. Okay, so this is my pass by value. Okay, so C++ offers these pointers, and because of that, we can actually change a local variable outside of where it was declared. So I'm going to go in there, I'm going to do, okay, void pass by pointer, and I'm going to make some other variable, call it j, but this one is going to be a pointer. Okay, I'm going to grab my prototype, I'm going to go after my main, right, where my definitions are, I'm going to throw that stuff in there, and now what I'm going to do is I'm going to say asterisk j is equal to 88, and then I'm going to do pass by pointer here, and what I'm going to do is I'm going to send the memory address of k to that. Okay, now when I do this, I already told you, what do you think is going to be the value for k here?
Would it be 88?
It would be 88. Okay, so if I run this thing again, you get to see the k is equal to 88, right? So what happens here is I am not passing the value. So if when you do a pass by value and you have just a regular parameter like this, you're simply passing this value 0. This here becomes equal to 0, and then I can show you that 0 if I wanted to, or do something with it. Okay, but when I do pass by pointer and I do ampersand k, I'm actually sending over the memory address of little k, or this k here, and this pointer j becomes equal to the memory address of k. So now changing this one, just like I was able to change little x by changing big X, that's the exact same thing that that's happening here. Make sense? Okay. All right. Any questions? Okay. So this is pass by value, pass by pointer. There's another way to do this in C++. Void pass by reference, and then you do int ampersand j, and then this will actually do pretty much the same kind of magic as the other one, except I think we just do j is equal to 80. Let's change it to 101. Okay, and the syntax is slightly different. So now I'm going to go do pass by reference, and I'm just going to do k. Okay, and when I show you the thing after, since I told you that it's going to work the same way as my pass by pointer, what is going to be the value of my k here? 101. Okay, let's see if it's true. Yes, k is equal to 101. Okay, so you might ask yourself, what's the difference between this one and this one? This is a pointer. We're passing a pointer. This is a passing by reference. Okay, the pointer here, I can repoint my variable j to another variable, right? So later on, I can maybe have like an int z, right, is equal to whatever, and I can say at j is equal to ampersand z. So I can repoint this thing. So originally j pointed to k, but then I can tell it, okay, well now point to something else. So I can repoint this pointer variable to whatever I want, any other variable of the integer type. Okay? But when I do an ampersand here, when I do the pass by reference, the j is basically fixed with the k, right? I cannot repoint j to anything else. It stays fixed, at, points to the same location as k. Make sense?
Can you say that one more time?
Okay, so when I do a pass by pointer, I can repoint my pointer variable to the memory address of another variable. When I do pass by reference, j here is fixed with k. It's connected to k, and I cannot repoint it to anything else. Is that right, Ellen? That's a yes. Okay. All right. So see, I'm not lying to you. Ellen confirms. So it's important to know the difference between pass by value, pass by pointer, pass by reference, because you're going to see these, any of these different ones are widely used in C++ language. And actually, that's one of the things that makes C++ confusing is the use of these pointers. Other languages like Python or Java, they don't have pointers. They just got rid of the pointers. Okay, they do take advantage of pass by reference, but it's kind of like behind the scenes. It's just always done that way. Okay, if you're going to pass a single variable into a function in Java and in Python, it's just pass by value. If you're going to be passing an array, since the array could be like a large structure of things, the automatic way to pass the whole thing into the function is pass by reference. So this is how it's done in other languages. In C++, there's a single pointer, there's a double pointer, there's a triple pointer, there's a pass by reference, there's a left pointer, there's a right pointer. They even came up with some other ones just to have fun with it. Okay, so that's one of the confusing parts. But don't worry, we're not going to get too much in depth with pointers. I just want you to understand how they work and just be able to use them for practical purposes. So that is pointers, pass by pointer, pass by reference. What is the difference between these? Now the next thing that I want to show you is recursion. And what is recursion? Well, it's another way to repeat something a bunch of times. So let's say I'm going to do, is there recursion in math? It comes from math, I bet. Yeah. I can't remember what class, what subject studies recursion?
Yeah, it's in discrete math.
It's in discrete math. Okay. So there you go, people. If you're listening to this video, take discrete math with Ellen. Ellen is awesome, and she'll teach you more about recursion. Okay? But anyway, here's my take on recursion. I'll give you a little something. So let's say we do a couple of ways to do loops, right? So we can do int I is equal to 0, I is less than 3, I plus plus, right? And if I do a cout, I'll do a for I equals I and L, right? So that's one way for me to make a loop. And then after this thing, I'm just going to do like a little separator. And I'm going to do it another way. I'm going to use a while loop. So int I is equal to 0, while I is less than 3. In here, I do my cout. This is my while loop. And then I'm going to do I plus plus in there. Right? So what this is going to generate is pretty much the same exact thing that this is going to generate, right? Except this is a little bit cleaner, less code, but whatever, same thing. All right? So here's your for loop, here's your while loop, right? Same kind of business. The I changes from 0 to 2 in increments of 1. And I can also do this with a do while, right? So technically there's another way to do it, but I'll skip that and I'll just show you how recursion works. So recursion is, I'm going to go in there, I'm going to make another function. I'm going to call it void recurse. All right, and I'm going to say int num. Okay, that's my prototype. I'm going to grab the thing, throw it after my main. Let's put it right here on top. Okay, and then what I'm going to do is I'm going to call my recurse right here, recurse. And I'm going to send, if I could spell it, recurse. What am I going for? I'm going for 0, 1, 2. So I'm going to start this thing at 0. And I'm going to go in there and I'm going to do a cout num recurse recurse num equals num and del. Okay? So what is this thing going to show me? I call the function, right? That's my call. I send the value of 0. The parameter num becomes equal to that value, and then I show you 0, right? If you don't believe it, there it is. Okay? So now what I'm going to do is, let me throw in this little separator in there. What I'm going to do is, I am going to tell this thing, call yourself with num plus 1. Okay? Now this is recursion. So, and this is, by the way, it's going to be an infinite recursion. Well, it's going to get stopped by the operating system very soon. So this is my call. I'm telling it, okay, go in there, send the 0, show the 0, then call yourself now with 0 plus 1, goes back, calls itself, shows the 1, then it calls itself with 1 plus 1, then goes back, shows the 2, etc., 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 etc. All right? So unlike a loop, so you can have a loop that happens like a million times or 2 million times or 3 million times. What happens with recursion is every time you make a function call, the CPU has, it's called a stack, right? So every time you call a function, you push it on the stack, right? Every time you return from the function, so when you get to the end of the function, you come back, you pop that function from the stack. But because I'm creating an infinite recursion, I'm going to keep packing things on the stack, and the stack is only so many spaces long, if you want to call it that. And it's only going to run so much time until it actually runs out of space and just the operating system kills it. So how many times it's going to run? I don't know. Let's find out. I'm going to run it. And it stopped right there. So actually it did pretty good. 174,000 times. So that's how many times I could call I can call a function before it calls quits. Okay, and after that, it actually tells you process finished with exit code 11. Remember, normally when the program exits with thumbs up, it's a exit code 1. This is exit code 11, so something that went wrong, right? What went wrong is you exceeded the stack. You did the stack overflow. So, all right, so one disadvantage of creating, so you can create some kind of a loop similar to a regular loop using recursion, but you can't, you cannot loop as many times with a recursive function as you could with a for loop. Also, because of this mechanism of how we push something on the stack and then we pop it off the stack and stuff like that. And by the way, you're going to learn stacks in the data structures class, which is the next one, the CSI 46. You're going to learn about the processors stack in the class that Rigo is taking, the CSI 28. He knows all about it, right? Okay, so so it happens slower. The actual looping is a slower loop, and there's an actual finite limit. It's only going to happen so many times. Sometimes it's going to happen like 9,000 times, and the program is going to kill it. Sometimes it might go up to like 174 or whatever, like right now. Okay, so what's the purpose of recursion? Well, it helps solve conceptually some certain types of problems, right? So, for example, there is a merge sort. If you Google merge sort, all right, and you look at it in Wikipedia, look at this list of numbers. First, the big list is split into little lists. Then each little list is further split until there's no more things to be split. And then we start assembling this thing in the correct order. So this is one kind of a sort. And by the way, I'm going to show you another kind of a sort next week, maybe. Well, next week for sure. I'm not sure if I'm going to be able to do it this week. But this kind of a sort algorithm is much easier implemented with recursion than it is done with an actual loops. Okay? When you get to the data structures class, I challenge you to do the merge sort without using recursion. Okay? And tell me how you did it, because it's hard. Okay? But if you do it recursively, it's actually conceptually much easier to tackle that problem with recursion. Okay, so there's some certain applications that, they're easier solved, or certain algorithms, if you want to call it, they're easier solved with recursion than with regular loop. That being said, if you ever have a chance to rewrite something, instead of using a recursion, you try to write it as a loop because it's going to run faster. You're not going to have to run into some kind of issues, that kind of stuff. Okay, recursion is also used in data structures when we traverse trees, but don't worry about that. We'll get to that when you get to that. Okay, so, and actually, this sorting algorithm is actually a lot more efficient, so it will run a lot faster, even though it's using recursion, which has its own overhead. It will be a lot faster to sort numbers using this way than it is using some other way, which I'm probably going to show you today. Okay, which is the bubble sort. All right, so going back to recursion, I haven't told you all of it. All right, you might think it's pretty straightforward. Let me try to blow your mind. So I'm going to go in there. I'm going to say, okay, if my num is less than 2, then call yourself. So now I created a condition. This thing is not going to go forever until the operating system kills it, or it runs out of stack. What's going to happen is it's going to call itself 3 times, hopefully, and then it's going to, so the first time I'm going to call it, it starts at 0. I'm going to show you the 0. Is 0 less than 2? Yes, it is. Call yourself with 0 plus 1. Now it's a 1. I show you the 1. Is 1 less than 2? Yes, it is. Call yourself with 1 plus 1. Then it's going to go with 2. Shows the 2. Is 2 less than 2? Nope. Stop right here. So that's where it stops calling itself. Okay, so I'm going to run this thing. And here's your recurse doing the same exact magic as your for loop and your while loop. Okay? Easy enough? Okay then. Tell me what's going to change if I move this. By the way, let me copy this. Copy this to here. Alright, so that's what it looked like when I had it this way, right? Now I'm just going to copy this, comment this out too. Yeah, let me copy it first. Alright, so this is what it looked like when I had it in this configuration. So now I'm going to go do this. I'm going to just grab this, move it from here to there. Now tell me what it's going to look like. Huh? Because you've already seen that, haven't you?
No.
Oh, that's a good guess. All right. Normally, I like to play this game with my students. I go around and I ask, if I have a bunch of students, they usually, all of them can't figure out the correct thing. It will be the opposite. Okay. So if you don't believe it, I'm going to run this thing now. All right. I'm going to run it, and now it shows 2, 1, 0. Why is that? That's one of the things that are kind of hard to visualize with recursion. So the first one made sense, right? You call the function, you show the number. If the number is less than something, call it again, show the next one, etc., etc., etc. But this one is a little bit more confusing. So let's have a look at how that one works. So I'm going to grab this piece, move it a little bit lower here. Okay, don't move it. There. Okay. So now let's have a look at, now I'm going to move the curly brackets to here. Okay, so here's what I'm going to do. I'm going to copy this, and I'm going to throw it in Excel. And let's open up a new spreadsheet, because 2 is not enough. Okay, so what happens? Initially, I am sending over a 0. Alright, let's go with orange. Right? So initially what I do is here, num is equal to 0, right? Is 0 less than 2? Yes, it is. So call yourself with 0 plus 1. So then I'm going to go in there, I'm going to copy this thing again. Okay. And I'm going to throw it, I don't know, right here. Okay, I'm going to grab my little arrow, copy that thing, paste it in here. So now, after this call, we're going to another call of this function, but this time I'm calling it with 0 plus 1, right? I'm going to write this in here just so you know what it is. All right, so this time it's going to be recurse 0 plus 1. Right? Which means that this number here is num is equal to 1. Okay? So num is equal to 1. Is 1 less than 2? Yes, it is. So now we're going to call this thing one more time. I'm going to copy it. I'm going to throw it right here. Okay, I'm going to get my little arrow, copy that, throw it in there too. All right? So now the next time I call this, right, I'm actually calling it, the num was 1 originally, right? It was called with a 1. Is 1 less than 2? Yes, it is. Call yourself with 1 plus 1. So recurse 1 plus 1. Okay? So what that means is now here, num is equal to 2. Yes? Well, num2 is not less than 2. So, right? 2 is not less than 2. So we're not going to call each other anymore. We're not going to call the function anymore, which is the first time we're going to get to the cout. So what's the first cout that I'm going to do? I'm going to do a cout recurse. Now I'm not going to write the whole thing, but cout 2, right? Because num was equal to 2. I'm going to do recurse num equals 2, right? With a little endl at the end. Okay? As soon as I show this cout, that is when my function ends. So the function goes from line 113 to line 119. When it gets to this curly bracket to the line 119, it's done. Now we're going to go back from where it was called. And it's time for me to pick a different color. Let's go with blue. Let me move this a little bit. Oops, wrong one. This one I want blue. Okay, so as soon as I get to this line right here, as soon as I get to line 19, I'm going to return right after I was called. Right? So I call this thing, and then I return right after it was called. Then the next thing that's left in this function after I call this, I'm going to show you the next cout. And what is the cout this time? Well, we had a num is equal to 1. So here I'm going to have a cout 1 endl. And that's the second thing that shows up, right? So that's why this is the first thing. You're getting to see the 2 first, then you get to see the 1 the 1 after. Then as soon as we're done with this function, then we're going to return back from where we're called from here, right? This instance of this function, we're going to return back right here, right? After this function is called, we return right after it was called. Let's put it right here. We return right after. The next thing that we're going to do is we're going to show this next cout. So cout, and then what's the value of num here? Well, I originally called it with a 0, so that's what the value of num is going to be here. So I show you the 0 and L, and this is why you actually show this 2, then you show the 1, then you show the 0. Make sense? It's confusing. Recursion is one of the more confusing things. I think probably even more confusing than pointers. Okay? But don't worry, we're not going to have to do a whole lot of this, but you still have to be comfortable with using recursion because we're going to get to use it quite a bit in the data structures class. So, any questions on this? All right. So that's recursion. I got that out of the way. And I already showed you the pointers, the reference, pass by value, pass by foreign pointers. I have time, so I'm going to show you the bubble sort. Okay, so let's say we have an array of numbers, right? So I'm running out of names here. Let's go with array z. So int z square brackets is equal to curly brackets 4, 3, 2, 1. Yes? Okay. So what I want to do here is, yes to everything? Can I borrow some money?
No.
Okay. Can you wash my car?
No.
Okay. Just checking. So, can you buy me lunch?
No.
Okay. So the next thing is I want to sort the array in ascending order, right? So I want to see it as 1, 2, 3, 4. Okay? How am I going to do this? Well, there's a couple of things that I need to be able to do. Okay? The first thing I need to do is I need to introduce to you how we're going to swap values. All right? So first, swap values. Okay, how are we going to swap values? Well, let's say I have, I'm running out of names. C, D, E. Okay, so there you go. I have an int C is equal to 1, and I have an int D is equal to 2. No, I already used the C. Let's call it E and F. Okay? So what I want to do is, here, before I get to show you how to sort something, what I want to do here is I want to have swap values so that E equals 2 and F equals 1. How do I do that?
You would make a third.
Awesome. So I make a third variable, temp, right? I say temp is equal to E, then I say E is equal to F, and then I say F is equal to temp. Okay, and what happens here is temp is equal to E, temp is equal to 1 here, then E is equal to F, so now E is equal to 2 and my F is equal to 2, they're both 2, and then the next step is F is equal to temp, which is equal to 1, so now I have E is equal to 2 and my F is equal to 1, right? So I swapped the values, I got what I wanted, okay? So now we're going to use this concept to do the bubble sort. And how is the bubble sort going to work? Well, remember this merge sort thing here? Let's go back and Google bubble sort. Bubble sort. And if you look at the bubble sort, here's a list of numbers in random order. What it's doing is it's comparing the left to the right, and if the left is bigger, it swaps their values. Right? Is 6 bigger than 3? Yep, swap their values. Go, now once this is swapped, go 1 down. Is 6 bigger than 1? Yep, swap their values. Move 1 down after that. Right? Is 6 bigger than 8? Nope, leave it as is. Go to the next one. Is 8 bigger than 7? Yep, swap their values. Then it's going to go down. So when it does this all the way, when it gets all the way to the end, what's going to happen is the biggest value, or the 8, is going to get moved all the way to the right. Or it will bubble up to the top, and that's why this thing is called bubble sort. Okay? Now once we're done with the 8, we're going to go back to the beginning, we're going to repeat this whole process. Is the 5 bigger than 3? And we'll keep doing this. The second time, what value is going to get moved where? Which value though?
Second biggest, right?
7 is going to get moved right next to the 8, right?
Yes.
Then I go back to the beginning, I'm going to grab the next biggest value, which is going to be my 6, and I'm going to move the 6 next to the 7, and if I keep repeating this over and over and over and over, eventually the whole thing is going to be sorted. So let's see how we're going to write a program to do this for me. And that's one of the applications of arrays. Now that you know arrays, we can do all kinds of fancy things like this. And by the way, with arrays, we're pretty much done with all the content that you need to know in this class. There's also files. You need to know how to be able to read and read from files, write to files. I'm also going to show you a little bit of objects and classes and stuff like that, but this is the meat of the class. Right? For me, the most important thing is for you to understand really the arrays, the loops, the ifs, the elses, the functions. If you got that, you're good. Okay? So let's do the bubble sort. And we're going to revisit these kind of things, the bubble sort in the data structures class, along with the merge sort and the select sort and the insert sort. There's a bunch of other sorts. Okay? So, the next thing that I'm going to do here is I'm going to do this. I'm going to write some comments, multi-line comments. Okay, so the first thing I want to do is I want to compare the 4 and the 3, right? These two values. Oh, so I'm going to be swapping the values, we said, only if the left one is bigger than the right one. So let me go in there and put an index. Index, so you remember, this is the 0, 1, 2, 3, right? So what I'm going to say is if the left one, in fact, why don't I not do comments? Let me just write the thing for real. Okay, so I'm going to do this. I'm going to say if which one is the first one? Z0, right? If Z0 is bigger than my Z1, right? In case you forget, I'll put that in there too, right? So this one here, right? This is my Z0, right? This last one is my Z3, right? And there's a few ones in the middle too. Okay, so this is my Z, this one is Z3, this one is Z0. So what I'm comparing is Z0, if Z0 bigger than Z1, is the left one bigger than the right? If they are, then I swap the thing. So I do, I'm just going to use my temp variable. Temp is equal to Z0. Then Z0 is equal to Z1. And then Z1 1 is equal to temp. Okay? So what I want to do is, I want to have like a quick way to show this array. And let's just try this. Cout Z equals, I don't think that's going to work. But we can try. Cout. Alright. Let's see what that shows me. Nah. It shows me the memory address of that. So that's not gonna work. So what I'm gonna do is I'm just gonna make a loop to show this. So I'm gonna say for int I is equal to 0, I is less than 4, right? There's 4 things, I plus plus, and then I'm going to show you cout zi with a little space after it. Oh, what the hell, I'm going to do the real thing. So here, this is my array, this is z equals curly brackets, and then I'm gonna do int I is here, and then this thing I'm gonna stop at 3, and I'm gonna show this, and then did I redeclare it? Okay, let me call it I'm really run out of names. K. This is gonna be K. I use K too. All right. M.
H.
You want H? All right. Just for Rigo. H. Even though he won't wash my car or give me money or buy me lunch. There you go. Okay. All right. So now this last one, I'm gonna do curly brackets \n. I'm gonna run it, and hopefully it shows the right way. There it is. And get rid of this line. Okay, so initially z is equal to this, I show you. Alright, it's equal to that. Okay? Then I want to see what it will look like after I do this line here. Right? So I'm going to just grab this thing here again. I'm going to copy it. And based on what we know about the bubble sorts, how is this thing going to get changed? Not yet. The 4 is going to go to the right, right? So the 4 is going to go end up here towards the end. And how exactly is it going to look like? Let me just run it. Oops. Oh, I forgot this piece. Run again. And now it's moved to the right. So I moved it here. Right? So the 4 moved from here to there. Yes?
Yes.
All right. So now the next thing I'm going to do is I'm going to grab this thing again. I'm going to copy it. I'm going to throw it right in there. All right. And this time what I'm going to do is I'm going to compare the next two. So now I'm going to be comparing this and this. All right. So initially I did a 0 and a 1. So now I got to do 1 and a 2. I'm going to change the 1 to 2. 2, 2, 2. I'm going to change my 0 to 1. 1, 1, 1. I'm going to run this thing again, and when I run it, what's going to happen to the 4? It's going to move to the right. So I run it again, and 3, 2, 4, 1. So now it's equal to this. All right? If I do it one more time, I'm going to grab this thing here now, and now the next thing I'm going to do, I already did the 1 and the 2. The next thing I got to do is I got to do the 2 and the 3. Right? I'm going to go in there. I'm going to throw that in there. I'm going to change the 2 to 3. 2 changes to 3. 1 changes to 2. All right? We're going to show this again. and run it. And now my 4 moved all the way to the end, right? So if I copy this thing, looks like this, right? All right. So, but that was a lot of copy pasting, right? So I don't want to do this. I did this one time, right? I did it another time, right? Then I did it another time. Okay, so what I'm going to do is I'm just going to erase these here. All right, just so I can kind of shorten this a little bit. We already convinced ourselves what this thing is equal to. Okay, and this is what it was equal to initially. I'm going to cut this out. All right, so that's what it was equal to initially. Okay, so now what I have to do is I have to come up with a way to, this was for 4 numbers, right? I have to figure out a way to do this for any number of numbers, right? I don't want to copy paste this thing a bunch of times. I want the program to do it for me. So what I'm going to do is I'm going to make up some variables, right? So let's say I'm going to call this variable, let's call it I, okay? Or let's call it P. Okay, this is my P, maybe a different name, M, okay? This is my M, and so the M initially starts at value 0, right? M is equal to 0, right? And this one here, I'm gonna call this one M plus 1, okay? So then I'm gonna go in there, I'm gonna see what the values for these variables are. So the M here goes to 1, right? And the M here goes to 2, and that's it, right? So this is my first value of, right? This is, so M equals 0 initially, and M equals to 2, M equals 2 at the end. Okay? But 2 is what? If I have 4 numbers, right? So 2 is equal to the size minus 2, right? So this array here, array Z, has a size of what? 4. Right? So there's 4 numbers in there. That means it's a size 4. So that means that the last one is actually equal to your size minus 2. And the reason I'm doing this is because I can have an array of 10,000 things or 1,000,000 things. I'm not going to go copy paste this thing a bunch of times. I need to figure out how many times to do it. Okay? So all I know is that it will start at 0, and I know that it will go to 2, which is size minus 2. Okay? So now the next thing that I'm going to do is I'm going to comment out this piece of code here. This was just so that I can visualize what happens. Ugh, damn it, I shouldn't have erased it. Whatever, I'm going to have to rewrite the whole thing again. Anyway, so what I'm going to do here now is I'm going to grab this here, right? I'm going to copy it, and I'm going to create a loop for int, we said M equals 0 initially, and then we said M is equal to, goes on until it's 2, right? So help me write this loop. M is equal to 0, M is less than what?
4, no, 5. Wait.
You said 2. If you said 2, then what are the values of M here? M equals 0, 1. I wanted a 2 also, right? So that's no good. So it's 3. 3. Right? So for 3 numbers, let's say I'm going to have an int size is equal to 4. Then this here is going to be equal to size minus 1. Okay? Because now I'm going to get the 0, 1, 2, correct? Alright. So then I just grab one of these here. Let's say I'm going to go with this one. Copy it. Throw it in there. I'm going to erase this stuff. Alright. So if you want, I can throw in some extra curly brackets in there to make you happy, because that's very important to me. So now what I'm going to do is I'm going to change this, the M, is the 0, right? So any 0 that I see, I change to m. And what did I say that my 1 is going to be? M plus 1. Okay? So wherever I see 0, I change it to m. Wherever I see a 1, I change it to m plus 1. So this here is an m plus 1. This one here is an m plus 1, right? And then I wish I didn't erase the show the array, because I'm going to have to write the thing again now. Int s is equal s cout. This is my z equals curly brackets for s is equal to 0. S is less than size minus 1. Size, oops, s plus plus. Then I do a cout, and I show you the, what's this thing called, zs, and then I show a little this, semicolon, come on, and this one here is going to be that. Okay? So when this is all done, basically this loop right here should do the same exact thing that me copying this thing 3 times did. So in other words, I should get this result when this loop has done doing its job. Okay? I run it, and there it is. 3214. Okay? So I got the same answer that I got from the loop. Alright, that's what I got. Okay. So this was just moving one number. What about the rest of the numbers? Well, I'm just going to do this thing again. I'm just going to copy this thing, copy it, paste it. All right, I'm going to run it again. Well, now what's going to happen? When I do it 2 times, now the 3 is going to get moved to this side, right? So we already moved the biggest number to the right. Now the second biggest number is going to get moved. 2, 1, 3, 4, right? So now it changed to 2, 1, 3, 4. So initially, when this loop did it, it was this at the end of this loop, and now it's this at the end of this loop. Okay, so I got one more pretty much number to move. Maybe grab this, copy it one more time, paste it in there. So now if I run this thing, I should actually have the thing sorted. 1, 2, 3, 4, sorted in ascending order. Okay, but just like I did before, I had to go in there and do this thing 3 times. Okay, which is actually kind of convenient because I also had to do this thing here 3 times. Which means that as many times as this loop happens, that is how many times I have to repeat it. So what I'm going to do is I'm going to go in there, I'm going to comment this out. Right? And then I'm going to do, what else? I'm going to grab this loop here. Right? And I'm going to nest it inside of another loop. So I'm going to say for int, I don't know, give me a letter. Q is equal to 0. Q is less than size minus 1, because I want this thing to happen as many times as this other loop is happening. And then Q plus plus, right? I go in there, curly brackets, another curly brackets. So now when this thing is done, when the end of this loop, I should actually have the whole thing sorted, right? In other words, this loop is going to repeat this loop 3 times, just like I did here, copy pasting it a bunch of times. So if I run it, now it is, okay, sorted. And this here is known as the bubble sort, okay? Some other things that you could do with arrays are you can look through an array to see how many times a certain number appears. Let's say how many 1s are in the array, okay? Let me just do that real quick, see if I can do it in 1 minute. All right, so let's say I have an array of t, int t, right, is equal to 1, 2, 1, 2, 3, 1, something like that, right? I want to count the number of ones. Int count ones, right, which is going to be equal to 0, right? This is an array of 1, 2, 3, 4, 5 things, right? So for int, so let's do this. S is equal to 0, S is less than 5, S plus plus, and then I'm going to do if my count, if my t, S is equal to 1, I'm going to count ones plus plus. So that's going to count how many ones I have in the array. Okay? I can also do another thing, which is, let's say I want to find the sum of the things in the array. Right? I go in there, I make an int sum is equal to 0, right? And I just do sum is equal to sum plus t s. Right? This is the sum of the all of the elements in the array. Okay? So those are some of the things that you should be able to do. You should be able to search through an array. You should be able to sort the array. You should be able to count the things in the array. And then I'll show you some other things later on. Okay? So if you're watching this video, and if you're not, for those of you in the class, that big crowd that's in the class, right? And there's tons of people in the class for those watching the videos. It's just, we can't, can't have seats for all of them. Right? So anyway, going back to this, so look at my other lecture for the Monday class and compared to what I did today, because I might have covered some extra things in there. Okay? So maybe you got the sort, maybe they didn't, but maybe I got some other things in there for their stuff. There's also ways for you to find the smallest and the largest numbers and that kind of things. So look at the lecture notes from the Monday class for examples for that. Okay? That's all I have. Thanks for coming and watching, and I expect your questions.